In a certain neighborhood, there are 500 people. 300 people own a car. So 300 people own a car. 150 own a motorcycle. And 100 of them don't have either. By randomly selecting a person in this neighborhood, determine the probability that. Before answering these questions, I will start with the Venn diagram so that we can see what's happening here. Okay, so put this represents the whole neighborhood, and let's say car and motorcycle. So these will be the people within this circle that will own a car. Over here we're gonna have the motorcycle, and outside we already know that there are 100 people that own neither. Okay, but first let's determine the probability, or actually the number of people that own both a car and a motorcycle, which will be represented by this overlap over here. How can we do that? Well, if we add up all these things, right? Number of people that have cars, number of people that have motorcycles, and neither, we're going to have 550 people in total. But they told us that there are only 500 people in the neighborhood, sorry. So this number is exceeding 500 by 50 people. So that is the overlap. So immediately I'm going to throw those 50 people right in the middle. They own both a car and a motorcycle. Okay, so how many people only have a car? Well, 300 have a car in total. So 300 minus 50 is 250. 150 on a motorcycle, so 100 only on a motorcycle but not a car. So that's the way we should distribute this. And question A is determine the probability that the person owns both a car and a motorcycle. So that would be the probability of C and M, which will be just 50 out of the whole sample space of 500 people. And that will simplify to 1 out of 10. So 10% chance of selecting both, or basically a person that has both a car and a motorcycle. Blanked out right there for a second. B, question B. What is the probability that the person owns at least one type of vehicle, a car or a motorcycle? So this is actually P, C, or M. And we're going to have 250 people that own a car, 50 that own both a car and a motorcycle, and 100 that own just a motorcycle. All over 500 people. And that's going to add up to 400 people out of 500, which is 4 out of 5. Another way of seeing this is that, well, if the person owns at least one type of vehicle, that means that they can't own any. So owning no vehicle at all is the complement of B, C, or M. So I could have subtracted the probability of selecting someone that doesn't have either vehicle from 1 to obtain the answer. And we would have gotten 4 out of 5 anyways, because 1 minus 1/5 is 4 out of 5. Okay, and I gave myself very little room to answer C. What is the probability that the person owns owns either a car or a motorcycle, but not both? Easy. We're going to take the 250 people that own a car, the 100 people that own a motorcycle, but don't own both. And we're going to have 350 out of 500, which will simplify into 7 out of 10. So 7 out of 10 people in this neighborhood own either a car or a motorcycle, but not both. That's it. So good luck with the other questions that I will present to you. And remember that practice makes perfect with this type of problem. Good luck.